Hey everyone, in the last section we talked about the library of parent functions. So the basic functions that make up all of, or the vast majority of functions themselves. Today we're going to talk about transformations. So in section 2.5 we take those parent functions and we shift them and stretch them and move them around the coordinate plane. So we'll learn how to do that today. So this is called graphing techniques, basic transformations. And I want to talk about a number of transformations in order. So the first one is called a vertical shift, which really just means taking a graph and moving it up and down on the axis. So if we have c as a positive real number, vertical shifts of a graph, vertical shifts up means that we take a function f of x and we add that c value to it. So plus c moves things in the up direction. Vertical shifts down, if we have minus c, our graph moves in the down direction. So we're going to work with the cubic function for right now. So I want to talk about the basic cubic function. Remember, a cubic function comes in from the bottom, squiggles like an S, and goes out on the top. Goes through the point 0, 0. And we're going to use that point in order to shift today. So if I'm drawing in a cubic function, looks something like this. So that's the basic parent function. F of x is equal to x cubed. Now, if I have a vertical shift, plus 2 means that I'm moving the entire graph up 2 units. So this point that was 0, 0, and that's its reference point, is moving up 2 and is now the point 0, 2. The rest of the graph is the same. So the shape is the same. Still coming in from the bottom, does a squiggly in the middle, goes out the top. The graph itself looks the same. It's just shifted up those 2 units. Similarly, if we're taking x cubed and we're subtracting 5, we're pushing it down 5 units. So the new reference point is the point 0, negative 5. And we have the same basic shape. So this is our cubic function, moved down 5 units. Now horizontal shifts, we also have horizontal shifts where vertical shifts they're taking our constant and putting it on the end. Horizontal shifts have the constant in the grouping symbol with the x. So if you have a squared function, that's when you have x minus 4 squared. That's a horizontal shift. Now, horizontal shifts move in the opposite direction of the sign. So if I'm moving to the right, then what I'll see is a negative sign in here. So negative signs move to the right. If I'm moving to the left, I have a positive sign in here, and that moves to the left. So again, we'll deal with the cubic function. Here's our basic cubic function. Now, if I have that cubic function in the parenthesis with the x minus 3 cubed, means that I'm moving 3 units in the positive direction. Remember, opposite of the sign. So that point that was 0, 0 has now moved 3 units to the right, and I'm starting at the point 3, 0 this time. So shaping points still looks the same, just move to the right. Now if I have x plus 3, that means I move to the left, opposite direction of the sign, moving 1 unit to the left. So now my reference point is the point negative 1, 0. Graph still shaped the same way. And there is a picture of my graph. So we have vertical shifts, moves in the same direction as the sign. Horizontal shifts, moves in the opposite direction of the sign. We also, we'll talk about some more shifts in a minute, but if I want to graph this absolute value function that has been shifted, remember that we start with the original. So the original absolute value function is the one that looks like a V. Looks something like this. Original point 0, 0. Now I'm going to dress my vertical shift first. So it's moving up 2 units. So based on the vertical shift only, I've moved up 2 units. So this is the +2 portion of it. Now I've also got a -5 portion of it. Remember, opposite way of the sign. So I'm moving in the positive direction 5 units. I'm still up 2. So my final result, my absolute value function, is over here. So this function starts at the point 252. And still opens and is shaped like the absolute value function. We do have other types of transformations that we need to go over. The next one is called reflections. So a reflection on the x-axis is when we make the whole function negative. So reflection on the x means that it's upside down. So we take a function, make the whole function negative, and it flips over the x-axis. Now, if we have our negative sign in with the grouping symbol in the x, in front of just the x part, not the whole function, then what that is a transformation over the y-axis. So it flips it from one side to the other. So square root function is the perfect one to demonstrate that on, because it's only on one side of the axis to start with. So our original function goes through the point 0, 0, opens like a bird wing, something like this. So that's our original. Now, if I have the negative out in front of the function, so negative square root of x, that is our x reflection, and it's flipping it upside down. So instead of opening up, it's going to open down. So here is our graph. Same graph, just opens down instead because it's upside down. Now h of x is the negative sign is on the inside of the square root. So if you're thinking about square roots, remember that you can only have 0 and positive values inside a square root. So this whole thing has to be positive in here, which means that I can only put in negative values for x. That's what makes it go from the positive side to the negative side and reflect over the y-axis. So I'm still touching the point 0, 0. That's fine. I don't have any transformations there, but I'm opening in this direction. So this is a reflection over the y-axis where the negative is in with the grouping symbol. We have stretching and shrinking vertically and horizontally. So let's talk about vertically first. Vertical stretching and shrinking is when we are multiplying our entire function by a multiple. So if we are taking a function and multiplying it by a number greater than 1, then we're making that function taller. It's like we're stretching it out on the y-axis. If we're taking that function and we're multiplying it by a fractional value between 0 and 1, it's like you take it and you squash it down. So it's called stretching and shrinking. Stretching for values greater than 1, shrinking for values that are fractional below 1. So if I take the x squared function, this is our basic parabola. If I were to multiply the whole thing by 2, it essentially makes it twice as tall. So my 0, 0 is still my reference point. In the original function, when we plug in 1, when we square 1, we get 1. In the new function, if I plug in 1, I square 1, I get 1, but then I have to multiply it by 2. So I get 2 instead. So this function at this point is twice as tall. Same thing, reflects over my y-axis, twice as tall as it was before. Now if I were to go plug in 2, 2 squared is 4 times 2 gives me 8. I'm already off of this graph at 4, or at 2, sorry. So this thing is much higher, much narrower than the original. 1/2, on the other hand, we plug in our value, square it, and then divide it by 2. So 0, 0 still. When I plug in 1 this time, instead of getting 1 back out, I get a 1/2. So I'm half as tall. When I plug in 2, instead of getting 4 back out, I get 2. So the basic shape of the function is still the same, but it's like it's been squashed. So shrinking. Now when I stretch or shrink horizontally, that's when the number is inside the grouping symbol with the X. The difference between the two, the rules are still the same. So if your number is bigger than 1, you're still stretching. And if your number is between 0 and 1, you're still making the graph wider, or you're shrinking it down. But it's more emphasized if it's in with the grouping symbol. So let me demonstrate. The original x squared function we still have. Just for comparison. So here's our goes through the origin 0, 0. These are all going to go through the origin. Now, if I'm looking at g of x this time, before in the last one when we were vertically stretching, we put in 1 and got back 2. For this one, if I put in 1, my x is equal to 1, I multiply by 2, so I have 2, and then I square it. So I'm squaring the doubled version. So that means I'm already at 4. Now if I plug in 2, 4 on the inside squared gives me 16. So I'm like way up here already at 2. This one is super skinny and narrow, very stretched up high. Much more emphasized than the vertical stretching. Same thing goes with the 1/2. So 0, 0 still goes through the origin. 1/2 means that it's going to be wide. Now if I put in 1 here, multiply by 1/2 and then square it, what I get is 1/4. So the thing is barely off the axis at 1. At 2, it finally gets to 1. At 4, it's going to get to 4. So this thing is very emphasized and wide. When you are graphing a transformation, the order is important. So the first thing that you have to do is you have to address any reflection. In reflections, you may have to factor. Typically, you may need to factor out a negative. We'll have an example of that in a moment. Then you deal with stretches or shrinks. Then you deal with shifts. Now shifts, the vertical and horizontal shifts, so you don't have to do them in any particular order. I know we've done vertical and then horizontal, but as long as you deal with the reflection and then the stretching first, the order is unimportant there. So be cautious when you're doing a compression or a reflection around the y-axis. You have to factor out that coefficient first. So see this negative x here? So we have to factor that negative x to the front inside the grouping symbol before we start. So f of x is really the square root of negative x minus 3. So this changes the direction of the shift. So it's important that we factor that out in the beginning. Remember that negative is going to flip it over the y-axis, but now that negative 3 is going to move it in the positive direction. So you have to be careful that you factor it out first. G of x here, also you have to factor any coefficients to the front. So if I'm factoring that to the front, I have a 3 and it's really x minus 5/3. So my horizontal shift is not 5. My horizontal shift is really 5/3. And then I have a vertical stretching, or sorry, a horizontal stretching piece of 3 in there. All right, so if I want to write an equation for this particular graph, I'm starting with the graph x squared. So this is my parent function. Y, or f of x, is equal to x squared. Now it's flipped upside down. So remember, upside down means the whole thing is negative. So far I have f of x is equal to negative something x squared. Now I'm moving down 2 units. So I have a minus 2 out here at the end. Also need to shift. So we're shifting in the negative direction, which means we're going to have a plus. And the number of units we've shifted is 3. So if I'm graphing that, flipping it over, 3 units in the positive direction, 2 units down. So this is our negative x plus 3 squared minus 2. All right, let's put it all together. Let's do some transformations of functions. So if I have this function f of x, negative square root of x plus 2 plus 3. First thing I want to think about is, what shape is this overall? So the shape of this one is the shape of the square root function. So that starts at the origin and opens like the bird wing. So we're starting with the square root function. Now the square root function here, we're reflecting. Now the reflection is outside the grouping symbol, which means it's a reflection upside down over the x-axis. So wherever we start, instead of opening up, we're going to be opening down. Now where we start depends on what our shift is. So plus 2 means we're moving 2 units to the left, to the negative side. Plus 3 means we're moving 3 units up. So starting at 0, 0, 2, 2 units to the left, 3 units up. Here is my starting point. Now that negative means I open down instead of opening up. So my graph looks something like this. Now when I have you graph something like this, this is what I expect. I don't expect you to plot a dozen points. I expect you to know the shape, how to shift it, how to reflect it. When you're stretching and compressing, I want to know that you know that it's wide or narrow. So if you are looking at something like 1/4, I need to know, looking at your graph, that you understand that 1/4 makes it wider and not like a regular parabola. So looking at the second one, this is a squared function. So my overall shape, f of x is equal to x squared. That's my overall shape. Looks like a parabola. Things I'm going to change about it. I have a vertical shrink, 1/4, so it's getting squat close to the axis. And then I'm moving 1 unit to the left, or sorry, to the right, and then 5 units down. So 1 unit to the right, 5 units down means I'm starting here. And then that 1/4 means it's going to open wide. So there's an estimate of that graph. All right, reach out to me if you have any questions. You will get to explore some graphs on your homework this week, and I'm happy to meet if you get stuck. Have a good day.